Hi and welcome to this video on powers and exponents and roots, maths made easy. So a power tells us how many times to multiply a base by itself. So usually represented in this way as a base, which is a number, and then to a power, which is written in this way like a little number. So 2 to the power 1 is 2, so that's multiplied by 1, 2 multiplied by 1 is 2. 2 to the power 2, or the exponent 2, is 2 times 2, which is 4. 2 to the power 3 is 2 multiplied by 2 multiplied by 2. So we're multiplying 2 by itself 3 times, which is 8. 2 to the power 4, multiply 2 by itself 4 times, so 2 multiplied by 2 multiplied by 2 multiplied by 2 is 16. Anything to the power 0 is 1. Anything to the power 1 is itself. So in this case we have the base 2 to the power 1 is itself, which is 2. 0 to any power or any exponent is 0. When we're multiplying and we have the same base and different exponents or any exponents, we add the exponents or add the powers. So here we have the same base and we're going to add the exponents. So 4 add 3, 7, and the base remains as itself as 2. When we're multiplying and we've got different bases but we've got the same exponent, then we can write it in this way, where we have the exponent on the outside and a multiplied by b, the two bases multiplied by each other. So we can then multiply out the bracket with the exponent, so we get a to the n multiplied by b to the n when we multiply that out. So for example, we have different bases here, 2 and 3, the same exponent 2, so we can rewrite this as 3 multiplied by 2 in brackets to the power of 2. When we multiply that out, we get 3 to the power 2 multiplied by 2 to the power 2. Division, same base, and we've got these different exponents. We can do this by subtracting the powers, so n minus m. For example, if we've got 2 to the power 8, 2 to the power 3, got the same base, we subtract the exponents. Subtract 8 minus 3. So 8 minus 3 is 5, base remains the same. Similarly, if we've got different bases and a division, we can rewrite this as a divided by b, the two bases divided by each other in brackets to the power n. And if we get this in as an example, we can rewrite this as 4 to the power 2 divided by 3 to the power 2. So we can go this way or this way across the equal sign. Powers, so if we've got a to the power n in brackets to the power m, we multiply the two powers together, so that's n multiplied by m. So 2 to the power 4 in brackets to the power 2, we multiply the 4 by the 2, gives us 8, base as 2. Here we're given an example which we've been through before, but I've used a whole number, so 1 and 3/5 is 8/5 to the power 3, so we distribute the 3, so this becomes 8 to the power 3 divided by 5 to the power 3. When we've got a negative exponent, the negative means the reciprocal of. So a reciprocal 1 over and then to the power n. So a to the minus n, the reciprocal 1 over a to the power n. So for example, if we've got 2 to the minus 4, so first of all, look at the minus. That's the reciprocal, so that's 1 over 2. 2 being the base, and then the power 4, so 2 to the power 4. If we have 8 divided by 5 in brackets to the minus 3, look at the minus first, so that's the reciprocal of 8 over 5, so that becomes 5 over 8. Then distribute the 3, we get 8 to the power 3, 5 to the power 3. Okay, so do the reciprocal. Anywhere there's a minus, do that first. Get the reciprocal, get that out of the way, and then anything else follows from there. So we'll go through some examples of that later. So if we got 1 over n as the exponent, a to the 1 over n, this is a root. So I remember it as if we had 1 over 2, as in this case 4 to the power half, this means the square root. Okay, so 4 to the power half is square root of 4. Similarly, if we had 4 to the 1/3, that would be cube root of 4. If we have a mixed fraction as the power, then the bottom number signifies the root, and this is the power. So we do the root first, so this would become 4 square root of 4. So the 2 signifying the square root, so this is square root of 4 to the power 3. So square root of 4 in brackets to the power 3. So do the square root first, do the root first, and then to the power. So just going to go over some examples, simplify this. So what we need to do is remember our rules. Y to the 4 in brackets multiplied by here the power 5, so 4 times 5 is 20. Here we got y to the power 4 multiplied by y to the 5, so we're going to add the powers, so that would be 12 y to the 9. Okay, so 4y power 20, 12y to the 9, power 9. So when we cancel, 4 into 12 goes 3 times, so that's y to the 20 over 3y9. Then we've got this division. So what do we do in division? We subtract the power, so 20 minus 9 is 11. So y to the power 11 over 3. Here we've got a division. We can divide this into 2 parts. We can divide the numbers first, so 6 divided by 3, and then use our rules of exponents to divide these powers, which means subtract the exponents. So here we've divided this sum into 2, this division. 4, 6 divided by 3 in brackets, and x to the power 4 divided by x to the power 2. 6 divided by 3 is 2. X to the power 4 divided by x to the power 2 is x to the power 2. 4 times 2 is 8. 8x to the power 2. Okay, some slightly difficult ones. So here we're going to distribute this 2 across this division. So this will become 4 to the power 2 a to the power 2. And then we've got to multiply by the b squared, or b to the power 2 by 2. So write it in this way. This is a multiplication. 2 to the power 2 is 2 times 2, which is 4. So this becomes 4 squared is 16, a squared, and b to the 2 times 2, which is 4, b to the power 4. Here we've got a negative, so remember what we said, we take care of that first and make that into a reciprocal, 1 over 4a to the power 2. And then distribute this 2, so this becomes 4 squared a squared, so 1 over 4 squared a squared.